Good morning. I am Regina, Assistant Professor, Department of Mathematics, Rohini College of Engineering and Technology. Today I am going to teach Cayley-Hamilton theorem. Course outcome. After completing the course, the students able to verify and use Cayley-Hamilton theorem to find the inverse of the non-singular matrix and positive integral power of the matrix. Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. Uses of Cayley-Hamilton theorem. To calculate the positive integral power of the matrix and the inverse of a non-singular square matrix. Verify Cayley-Hamilton theorem. Find a power 4 and a inverse where capital A is equal to 2 minus 1 2 minus 1 2 minus 1 1 minus 1 2. The characteristic equation of A is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. So first we have to find s1, s2, s3 and substitute the values in this characteristic equation. S1 is the sum of the main diagonal elements or leading diagonal. So the leading diagonal elements are 2, 2, 2. So we have to add this and we get 6. This is S1. The next find S2. S2 is the sum of the minors of the leading diagonal elements. Minor of 2 is, so we have to remove the corresponding column and row. We get 2 minus 1 minus 1 2. So we have to find the determinant of this one. The next, take the next diagonal 2, remove the row and column and row. We get 2 2 1 2. Plus take the last diagonal 2, remove the column and row, we get 2 minus 1 minus 1 2. We have to find the determinant of these values. 2 into 2 minus 1 into minus 1. So 4 minus 1 plus 2 into 2 minus 1 into 2. So plus 2 into 2 minus 1 into minus 1. So 4 minus 1 3, 4 minus 2 2, 4 minus 1 3. After simplifying we get 8. So S3 is equal to determinant of the given matrix. Determinant of the given matrix is 2 into, remove the column and row. So we get 2 into 2 minus 1 into minus 1. So 4 minus 1 minus 1 into, so plus 1 minus into minus plus 1 into, remove the column and row, minus 1 into 2 minus 2 minus 1 into minus 1. So plus 1. Plus 2 into, remove the column and row, minus 1 into minus 1, 1 minus 2. So after simplifying this, 2 into 3 plus 1 into minus 1 plus 2 into minus 1. So 6 minus 1 minus 2 equal to 3. So the characteristic equation of the lambda given matrix A is lambda cube minus s1 lambda. S1 is 6, s2 is 8, s3 is 3. So substitute, we get this lambda cube minus 6 lambda square plus 8 lambda minus 3 is equal to 0. So we have to verify the Cayley-Hamilton theorem. The Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. So the equation is a cube minus 6a square plus 8a minus 3i is equal to 0. So in the place of lambda we have to substitute a. So the given matrix should satisfy this equation. So we have to verify this. We have to find the LHS value. We have to get this 0. 0 means 0 matrix. 3 cross 3 0 matrix. So to verify this, we have to find a cube a square values. First to find a square. A square is given matrix A into A. This is the matrix A into A. We have to multiply this. To multiply this one, we have to multiply the row and column. Minus 2 into minus 2 plus minus 1 into minus 1 plus 2 into 1. So adding this, we get 7. Like the same way, we have to find each and every term. So each corresponding column in row into column. First element, this row into this column, second element, this row into this column, third element. Like that way, we have to find all the elements. So next to find a cube. A cube means a square into a or a into a square. So A value is this one, given matrix. A square is this one. We have to multiply both. We get this one. So after that we have to substitute all the values. A cube value, A cube matrix minus 6 into A square matrix, this one, plus 8 into given matrix A minus 3 into identity matrix. 3 cross 3 identity matrix is 1 0 0 0 1 0 0 0 1. So next we have to multiply 6 by this matrix, 6 into 7. Each and every time we have to multiply by 6. Here each and every time we have to multiply by 8. Here we have to multiply by 3. After multiplying we get this one. So finally we have to add 29. Here minus sign is outside. So this minus is common for all the elements in this matrix. Here also this minus is common for all the elements. So we have to include this minus also. 29 minus 42 plus 16 minus 3. The value is 0. Like the same way, minus 28 minus into minus plus 36 minus 8 plus 0. That value is 0. 38 minus 54 plus 16 minus 0. Answer is 0. Like that way we have to find all the elements. Next to find a power 4. So here a cube is equal to 6a square minus 8a plus 3i. So here we have to, this is the characteristic equation. Okay, the next we have to multiply a both sides. So we get a power 4 is equal to 6a cube minus 8a square plus 3 into a. So 6 into a cube. So we have to substitute a cube value here. Minus 8a square plus 3a. So 6 multiplied by each and every term. 6 into 6, 36a square. 6 into minus 8, 48a. Plus 3 into 6, 18i. Minus 8a square plus 3a. So we get 36a square minus 8a square, 28a square, minus 48a plus 3a minus 45a plus 18i. So this is a power 4. So we have to substitute a 28 into a square values. Substitute here, minus 45 into given matrix A plus 18 into I matrix, unit matrix. So next we have to simplify this matrices. We have to multiply 28 by this each and every term of this matrix. Here multiply each and every term by 45. Here multiply by 18. We get this one. After that this minus is common for all the elements. So we have to multiply each and every term by minus sign. So we get 196 minus 90 plus 18, that is equal to 124, minus 168 minus into minus plus 45 plus 0, this is equal to 120 minus 123. Like that way we have to find all the elements. The next find A inverse. So to find A inverse we have to multiply A inverse by the given eigenvectors characteristic equation. So equation 1 into A inverse. The answer is A square minus 6a plus 8i minus 3 into A inverse equal to 0. So here we need A inverse. So minus 3A inverse, send this into right side. So we get 3A into A inverse. 3 into A inverse equal to A square minus 6a plus 8i. So 3 into A inverse equal to, here write here A square value minus 6 into A matrix plus 8 into I matrix. Multiply by 6, each and every term by 6. Here multiply by 8. So we get this one. We have to add each and every term. 7 minus 12 plus 8. The answer is 3. So like that way we have to add every elements. So we get 3A inverse equal to this one. Next we have to find A inverse. So send this 3 right side. So we get 1 by 3 into this one. This is A inverse. Some important questions from this topic. Thank you.